Now, you can extend the waterfall model to cover all 3 spatial dimensions, and that gives you this, a real simulation of space flowing into a static black hole, made by my friend Alessandro from ScienceClick.
You heard right. The author is really talking about the movement of space. This video is from the Veritasium channel, and you may have already seen it. But in this video the author uses the movement of space somewhat differently than it is used in the theory of moving space. And this is not the first or only example of how the movement of space is used to explain gravity. But those who do this are not even aware of the potential hidden behind this idea. And now I will explain this to you. The very idea of moving space is a bit counterintuitive and confusing. And this is due to the fact that in our minds the word space is understood as 2 completely different concepts. And some viewers who heard about the movement of space for the first time have problems perceiving this idea. And if you have a similar reaction, then you should watch video number 3.1, which will answer the contradictions that most often arise when you first hear about the movement of space. But the movement of space is inherent in Einstein's equations themselves, since the well-known curvature of space describes gravitational interaction in statics, that is, without taking into account time.
Finally, the most important issue with this representation is the fact that our diagram completely ignores the time dimension.
And it's true, if you mentally stop time, then some analogy to the movement of space can be the curvature of space, which would only show with what acceleration and in what direction the body should move. But if this process is considered in dynamics, taking into account time, then the equations do not speak about the curvature of space, but about the movement of space.
In fact, it is the time component of the curvature which explains gravity.
This interpretation of gravity is called the new visualization of general relativity. You can find out more about this on the ScienceClick channel. And this was the first, truly serious step towards popularizing the idea of the movement of space. The second important step happened recently. On the Veritasium channel with a multi-million audience, a video was released about the consequences of solutions to Einstein's equations. And in this video, the author uses the idea of movement of space several times to explain gravitational phenomena. And the description of the event horizon of a black hole is very similar to the description of the event horizon in the theory of moving space.
Another way to visualize what's going on is by describing space as flowing in towards the black hole, like a waterfall. As you get closer, space starts flowing in faster and faster. At the horizon, space falls in as fast as the photons are swimming.
And this event, in turn, brings closer the moment when the idea of the movement of space will be perceived as something natural, normal, and taken for granted. But why do we need a theory of moving space if there is a general theory of relativity? And if Einstein's equations imply the movement of space, then there is no need to change anything. And the answer to the question lies in 2 problems that are relevant today. The first is the complexity of calculations in general relativity. The fact is that the theory of relativity is a set of equations with tensors. And solving these equations is a very, very difficult task, despite its apparent simplicity. And the general theory of relativity is actually used extremely rarely, due to the complexity of the calculations. On the other hand, why such difficulties, when it is possible to use very simple and well-tested calculation methods on the scale of the solar system? This may be news to some of you, but the virial theorem is used to calculate the velocities of stars and galaxies. More precisely, the mass of matter inside the orbit of these stars is determined by the velocities of the stars. This mass is called virial mass or dynamic mass. This is the relationship between mass and speed, which astronomers, observing the movement of planets, determined even before Newton. From this relationship, you can quite simply obtain the law of universal gravitation. And since the results of such calculations, on the scale of the solar system, are completely consistent with Einstein's theory, there are no obstacles to using these calculation methods on the scale of galaxies and galaxy clusters. The second problem is that even if some science popularizers use the movement of space, they use it only as a way to visually explain gravity. But, if scientists considered instead of the curvature of space, the movement of space, but to consider the movement of space not just as a spectacular way of visualizing the theory of relativity, but as the real movement of space, which affects the laws of inertia and, accordingly, gravity. Then solutions to the most important problems of astrophysics would be revealed to them. That same new physics would be discovered, which astronomers sometimes talk about when they are faced with insoluble problems. And this, without exaggeration, can be called new physics. Because on the scale of the solar system, the speed of space is so small that it does not affect the functioning of physics as we know it. But on the scale of galaxies and galaxy clusters, flows of space are formed at very high speeds. And since gravity is a manifestation of inertia, and any change in the laws of inertia is a change in the laws of gravity, the flows of space at high speeds simply cannot but affect the laws of inertia, and the laws of physics in general. And these flows of space create previously unknown effects of inertia, and that is why gravity on the scale of galaxies and galaxy clusters is so strange and cannot be explained, either through dark matter or through modified Newtonian dynamics. The distribution of matter and the speed of space are interconnected. And this relationship provides the key to understanding why matter in a galaxy is arranged in such a way that it produces flat rotation curves, and thus solves the mystery of flat rotation curves. This in turn explains why visible matter in galaxies completely ignores hypothetical dark matter, the mass of which is usually many times greater. And thus another problem disappears, which is called the problem of fine-tuning the parameters of the galaxy, or the problem of explaining the collusion of dark and visible matter. And accordingly it becomes clear why the luminosity profiles of disk galaxies have a certain universal appearance. But most importantly, this relationship explains the dynamics of galactic disks without the need for any dark matter to exist. These altered laws of inertia affect the motion of stars in our galaxy. And yet there is still no clear explanation for the anisotropy of the velocities of halo stars. It is simply impossible to choose a scenario in which such anisotropy will occur. This looks the same as in the case of flat rotation curves of galaxies. If the rotation curves of disk galaxies look like someone is artificially adjusting the distribution of dark and visible matter, that same someone artificially sorts the stars in our galaxy and gives them the corresponding speeds. And if in the case of flat curves this is explained by the relationship between the speed of space and the distribution of matter, then in the case of halo stars, one inertial effect acts on all bodies in the galaxy, with the exception of bodies that have strictly radial speed. This is how this anisotropy is formed. Under the influence of the same effect, stars in a galaxy can have very high speeds, but still remain in their orbits. And at the same time, no dark matter is needed. There are also other manifestations of anomalous gravity associated with the movement of space. You can learn more about all this in video number 9. And there are also other examples where something looks like it was set up artificially by someone. And this is natural if you look at the universe through a distorted prism, through an imperfect theoretical paradigm. If the main theory is not complete, then various anomalies and inconsistencies will be ubiquitous. This has already happened many times in our history. When something seemed anomalous or man-made, it later turned out to be simply our misunderstanding of what was happening. For example, Ptolemy's epicycles in the geocentric system. While people believed that the Sun and all the planets revolved around the Earth, all the movements of the planets seemed extremely complex. But as soon as the Sun was placed in the center of everything, everything became simple and clear. If you go down from the scale of galaxies and galaxy clusters to the scale of atoms, you can see that space entering a proton or neutron accelerates tens of millions of times per second. And thus the conditions are created for neutrons and protons to combine together. And to explain this connection there is no need to create nuclear strong and nuclear weak interactions. It's all the same gravity. The movement of space solves one of the most important problems of modern physics. More precisely, not a problem, but a huge white spot in theoretical physics. Everyone has somehow forgotten, but the principle of equivalence still has no theoretical basis. This is the principle of the equivalence of gravity and inertia, the equivalence of gravitational mass and inertial mass. Once this principle was postulated but without theoretical justification. and therefore this principle was repeatedly subjected to experimental testing to verify the correctness of this postulate. And here you need to understand that the curvature of space does not prove this equivalence in any way. It can only be proven by assuming the motion of space. And only under such conditions, in Einstein's famous thought experiment, everything falls into place, and time dilation in a gravitational field becomes understandable and logical. And if the idea of the movement of space had been generally accepted in ancient times, then Newton's genius would not have been needed to create the law of universal gravitation. Within the framework of the concept of moving space, this task is within the capabilities of a first-year physics student. And these are not all the advantages that the concept or hypothesis of moving space provides, which I call a theory in my videos. You can learn more by watching all the videos in the theory playlist. I don't know if the idea of space movement will become even more popular, or if it will just remain as an interesting way to visualize gravity. But if this happens, and the movement of space begins to be perceived as an effect that affects the laws of inertia and gravity, then a real revolution awaits physics.